In this video I'm going to illustrate how some of these toolbar buttons can be used. The one that I'm going to focus on primarily will be the sum columns, but in the process of using this toolbar button I want to verify that the summation is valid, and I'll do that using the PCA button. I will also check that the data is in a state in readiness for summation by ensuring that I haven't left any hanging processing on the data using a toolbar button that is select process blocks. So we'll start off by reviewing this data set, and it is a set of spectra that were measured from a vanadium foil. The vanadium foil has oxidized, so there's a native oxide, and there is some contamination in the form of adventitious carbon. So what I would like to do is verify by overlaying in the active tile a set of measurements of vanadium and oxygen 1s, and by using the PCA button I'm going to verify that within these data there is only one shape that represents signal and other shapes are just noise. And the PCA calculation does precisely that. It will calculate the maximum variance in the data, and that represents the first abstract factor, and the subsequent abstract factors represent what is left in the data once you've removed the first abstract factor. So here we see the other abstract factors that are calculated and represent noise. So in terms of the vanadium and the oxygen, we have spectra. The vanadium and the oxygen, this is vanadium, this is oxygen, that all the information that would be interested in if we wanted to calculate the relative proportions of oxygen to vanadium or perform some peak fitting, we could do this with confidence using the spectrum with the better signal to noise that will be obtained by summing these data. Let me just verify that the same is true for the survey data. So I've now calculated the abstract factors from the survey data. Let me just display the data so that I can see I've got one abstract factor that looks like the spectrum, and all these other abstract factors look like noise. These are very characteristic of Poisson noise. Pulse counted data is that the noise is the square root of the counts per bin. So where we have a low background we see low noise, and where we have a higher background we see more noise. So this is very consistent with all of these data producing exactly the same shape. Let me just return that to the raw state, and then I will use this button here to verify that I'm going to sum only the raw data. I don't want to sum process data, I would need just the raw data in this case. So pressing this button will select the VAMAS blocks for which processing is still a part of the VAMAS block. So if I want to return that to the raw state, I will use the reset processing button and just verify again I've got no processing. I'm now in a position where I can make a selection and then press the sum button because I have all the data in the raw state, the columns are selected, and I produce a new VAMAS file with the data now summed and with superior signal compared to noise.